All right, we're going to talk about sequences today. A sequence, by definition, like not talking about math, talking about like if you Googled the word sequence without math involved. A sequence is often called like a pattern. Oop, I can spell. A pattern, or like an order to things. Like you have these things going in order. So I can look at a picture and I can see a pattern. Like maybe you can see that every single time I have a new picture, I have a new set of dots going around. So if let's say I plug in 1, this is step 1, I get out 1 dot. Step 2, I get out 5 dots. Step 3, I get out 9 dots. If I were to go beyond this and say, okay, what would the 4th one look like? Well, we could totally draw the picture. Now there's 3 dots coming out of each leg of the X here, and that would be a total of 13 dots. So my pattern here, maybe we can see, is I'm adding 4 each time, meaning I'm adding, a dot to each leg every time. So if I went to step 4, I'd plug in 4 and I would get out 13. Now I'm gonna, go beyond. This is our arithmetic sequence. So that's what I'm gonna base this formula off of. If I wanna write a formula for the nth term, meaning just I could plug in anything, I would say, well, my slope, right, quote unquote, my slope is 4 because I'm changing by 4 each time. And then my first term, where I started, was 1. That's like the equivalent of our y-intercept. So with this formula now, I don't have to draw the picture all the way up to step 8 to figure it out. I can just plug in 8 into my formula. So I could say 4 times 8 minus 1 plus 1. And I would get, 28 plus 1, 29. I'd get 29 dots. So we're used to equation notation, and that's great. That's y equals mx plus b. This is probably more similar to point slope form. So if you remember y minus y1, that's kind of what we're going off of here. Like that should look very similar to this. And this is our arithmetic sequence with sequence notation. So N is going to stand for number. D stands for difference. So we talked about our common difference in 9.1. That's going to be like our slope. And A1 means step 1, your first term. Okay, so with that said, let's try it out. Find the common difference of the arithmetic sequence. So sometimes you can just see it. Sometimes we can look at this and we can go, I think that's adding by 5. Because it is. But heaven forbid I couldn't tell. Then I'm going to do my y2 minus y1. I'm going to do my half of the slope formula, my mini slope formula. Second minus first. What I'm referencing we talked about in 9.1. So I take my second term, which is always the second one in the list, and I take my first term and I subtract them. So negative 14 minus negative 19. 2 negatives make a positive. Negative 14 plus 19 is 5. So if I couldn't tell that that was adding by 5 each time, then I could do my common difference formula, second minus first, and I could find the common difference. Okay, write a formula. So my formula that we saw was d times n minus 1 plus a1. D stands for difference, n is number, and in this case it's just going to stay n, and a1 is the first term. So now I don't have a picture, I just have a number, and so the first term is going to just be the first term. I'm going to put it in front just because. Okay, 14 is my first term because it told me. And then I do my little mini second minus first formula. 10 minus 14 is -4. So that means if I couldn't tell already, this is subtracting 4 each time. And -1. That is my answer. You don't have to find a term in the sequence. You just say, that's the formula for it. Finding the 96th term. So that means I want the 96th step. Like, in this list, which number would be the 96th number? So I'm going to use my second minus first. And I'm going to find my pattern. So -14 minus -3 is -11. So that's going to be my D. That's going to be my slope, how much I'm changing each time. My first term is -3 plus -11 times n minus 1, but this time n is 96. So then I'm going to take my calculator, and I get -1048. And that is what I put in this box. So if they give me a number, like they want an actual step, they want an actual number in the list, then I give them a number. But if they want the formula, then I give them the formula. Okay, last section of your homework is going to look like this. It's the slope formula. Okay, first term, A1 is 4. So A1 equals 4. That means if I plug in 1 x value, I get out 4. And the third term, that means if I plug in 3, I get out 24. And from there, I can label my stuff and do the slope formula, which is y2 minus y1 over x2 minus x1. So 24 minus 4 over 3 minus 1. 20 over 2, which is 10. Okay, that's arithmetic sequences. Let's look at geometric. This should look a lot like exponential functions because it is. Again, the letters are different. This is still my first term. R stands for ratio, still your growth and decay factor. And N is still your number or your term. Okay, so I just want to show that these are exponential. So I look here and I see my pattern is I'm timesing by 3. My domain is 1, 3, 9, 27. My range is, or excuse me, my domain is 1, 2, 3, 4. My range is 1, 3, 9, and so on. So if I want to graph this, then I would go, okay, domain is 1, 1, 2, 3, 3, 9, gosh, there-ish. And so what's happening is if I were to draw a line, this would be my upwards exponential curve. This time, I'm dividing by 2. My domain is still the counting numbers, 1, 2, 3, 4. And my range is 16, 8, 4, 2, ... All right, I don't think my graph goes up to 16, but it's up there somewhere. And then 2, 8, 4, 5, 6, 7, 8, then 3, 4, 4, 2, 5, 1, 6.5. So now I have this exponential curve that's going down. These are exponential. So a geometric sequence is just an exponential function. We're kind of looking at it in a little bit of a different way, more on the pattern side of things, less on the real world taxes, interest in a bank kind of way. We are growing by multiplying because this is exponential. So let's try it out. Instead of a common difference formula, I have a common ratio formula. This was the other one we talked about in 9.1. And instead of being second minus first, it's second divided by the first. And so I'm going to take 39 and divide by negative 13, because that's my second term and my first term. And if I put that in my calculator, I get negative 3. So if we take a look, what's happening each time is I'm timesing by negative 3. Let's try it again. Negative 81 divided by negative 9. So I am multiplying each time by 9. All right, if I want to find the formula, so they're asking for the formula, not for a number. They're asking for me to write out the formula. So formula was A1 times the ratio to the n minus 1. So my first term is 96. My ratio is going to be second term over first term to the n minus 1. Now Delta Math is going to want us to simplify that. That simplifies to a fourth. So this is what goes in the box. So what that means is I'm multiplying by a fourth or I'm dividing by 4. Okay, each time this is a divide by 4, or I can also call that multiplying by 1/4. That goes in the box. Find the 8th term of this one. So I'm going to take this formula, and instead of n, I'm going to put 8, and then I'm going to plug it in, and we get, oh, I don't know why it says whole number. We get 0.005. Well, you get more than that, but I'm rounding. Okay, so that is sequences. And those are the kinds of questions you can be asked on your homework. So email me if you have any questions, and have a good day.